Hello again. Welcome to Block 2, Use of Algebraic Notation, Lesson 9. I'll share my screen. So, in your previous lesson, you learnt about uh, use of two-step function machines or two-step operations, but your input was either diagrams or letters. So you really built a good foundation of how the principles of algebra work. In today's lesson, you're going to learn finding the functions when the expressions are given to you. So you have an input, you have an output, and then you have to find what the function is. Now, this is a very important skill because you'll be using inverse operations to find out what the missing functions are. But before we start, I would like you to do the retrieval practice so that you can recall what you learned in your previous lesson. You can pause the video and do the retrieval practice in 3 minutes. Now, assuming you have paused the video and you've really thought about these questions, here are the answers. So let's discuss them. The first one, you were asked to work out the output of the two-step function machines. Well, you know by now that with function machines, when you put in an output, this function machine is simply telling you that you multiply by 5 and then you subtract 3. Okay, so 8 times 5 is 40. 40 minus 3 is 37. And then you're being asked for the second part of the question, what's the same about the function machines and what's different? Okay, if you recall in our previous lesson, we did say that sometimes the order of operations affects the result, and that this is a clear example of that happening. So you can see here the operation is the order of the operation is changed, and that affected the result. Next, you're told to complete the function machine. Okay, so you're given 8. 8 squared is 64. 64, you're told to subtract it from 90. Your answer will be 26. All right, it's time for us to do some learning. Well, if I give you this function machine, we do not know what's going on in there, but we have an output. Well, you would think, okay, I had k as the input, but now I have 3k at 5. So at some point, we would have added 5 and then we would have multiplied k by 3. So we would have made 3 lots of k, so 3 times bigger. Now, initially, if you think about it, we could do it like this, okay? So you could say, okay, I think this is the answer, right? But here is what happens when you really take your time to work out what your thinking is. So whatever you thought the answer was, you can write it out and then work it out, because you already know how to use from your previous lesson, how to use two-step function machines when your input is a term, a letter, right? An algebraic term, which is k, or a letter, which is k. So if you do that, here is what you get. Okay. So k at 5 looks like this in a block model. Times 3 means we need to make 3 lots of that. So it becomes this. Now, if we put these together, all the k's together, we actually have 3k add 15. This is what it becomes. But that is not what the output is, so we're wrong somewhere. Well, let's change the order of the operation and see whether it will affect our results. Because remember, we've learned, even you saw at during while you were doing the retrieval practice, that the order of operations can affect the result. Maybe this will help us here. If we do that, then it means we're going to be multiplying by 3. So let's try that. So we multiply by 3 first before we add 5. It looks like that works, doesn't it? Because this gives us this result, which is the output. So actually, our operation should change its order. So we should change the order of the operation, and that answers the question. So it's really important what we've learned here, that if you are thinking of an answer to the missing operations in the function machine, it's important you work it out, write it out to see whether it matches with the answer that you've already been given, or with the algebraic expression that you've already been given as the output. Okay, if it doesn't, then try changing the order of operations to see whether that would affect your result and then give you the right answer. So here is another one. This one, x is our input, our output is x minus 3 over 2. Initially, you would think, okay, here there are two things that have happened. We have an input x, we've subtracted 3, and then we're dividing by 2. But in which order? Initially, if you try this, okay, if you're thinking, you say, okay, let me try this. I'll take away 3, I'll subtract 3 before I divide by 2. If you take your time to write this out, here is what happens. X divided by 2 will look like this. Okay, you should remember, early lessons in algebra, we already know how to write these algebraic terms. So x divided by 2. Now we subtract 3. So this is what it would look like. Now you start thinking, but that doesn't look exactly like the output I was given. So you need to reverse, you need to change the order of operation. And that becomes x subtract 3. It's beginning to look like we're going to get the right thing. And then divided by 2. Okay? Now, there's something really important you need to know. In order to be able to find out what is missing in the function machines, to find out the operations, it's important that you can read algebraic expressions properly. You can actually read what is going on, really going on properly. So, for example, this one is 7m. So it means you need 7 lots of m first before you add 4. So this is multiply m by 7, then add 4. Now have a think, and you can discuss this with anyone, who's watching this video with you. How would you read these expressions? Okay, because this is a fundamental skill you need to have so that you can actually decode or find out how to work backwards. If you need to do that, do the inverse operations to find out the missing operations in the function machines. Okay, here is what they are. So this one means we add 4 to m first before we multiply by 7. So we do what's in the brackets before we multiply by 7. This one is you add 4 to m, then you divide by 7. And then this one, you divide m by 7, then you add 4. Okay? So, what we've learned so far is that for you to be able to find out the missing operations in a function machine when you're given the output and the input, you need to think about what changed between the input and the output. Now, thinking about the operations, you can first work out whatever order you think the operations are. You can first work out what the result will be. And then if it doesn't work, if it doesn't correspond or match with your output which you were given, then you can reverse the order of the operation and see whether it fixes the problem. Okay, I would like you to answer questions 1 and 2. So pause the video, think about what you've learned so far, and work through this problem in 4 minutes. You can take longer, you can take shorter time to do it. Assuming you've paused the video and you've worked through it, here are the answers. Discuss them quickly. So for question 1, you asked to complete the function machines with the correct number and operation. So here, this is g multiplied by 4 plus 3. Why? You can clearly see that we have 4g at 3. So if we have 4g times 4, that's already 4g, and then in the end we have 4g at 3, it means the operation would have been to add 3. Here you can clearly see that we already have add 5. Okay, h divided by 2, add 5. So clearly that should be a divide by 2. Okay, so those are the other answers. I'll let you mark your work quickly. Then this one involves 2 steps. Okay, so here we have 5h plus 2. Our input was h, so clearly we would have multiplied by 5 or made 5 lots of h before adding 2, or in either way you were thinking. I don't know how you thought about it, but let's say you added 2 first before multiplying by 5. Of course, you would see that the result doesn't match 5h plus 2. So these are the correct order of the operations that will give you the correct results. Okay, we move on. So pause the video and answer questions 3 and 4. You can take 4 minutes to do this as well. Let's say you've paused the video and you've actually thought about the solutions to these problems. Here are the answers. Here is the answer to question 3. Alex is completing this function machine. She fills in the gaps like this, so which is shown below here. Explain the mistake Alex has made. So clearly she has done them in the wrong order, because you can see h multiplied by 7 will give us 7h add 3. It's not going to look like what we want, which is to add 3 to h first. So remember, it's important to know how to read these expressions before you multiply everything by 7. Here is the answer to question 4. Here again, it's important you think about the order of the operations. Of course, you can discuss with a partner or someone you're watching the video with or studying with this here. The question, what is the same? What is different about each pair of the function machines? Okay. All right. Let's do some new learning. What about if we have a function machine given to us where we only need to look for one of the missing operations in the function machines. So remember, we're working with two-step function machines. So here we have an output 13D at 7. Here we added 7 before we got the output. So clearly, remember from one of your early lessons, you know that to find out what came before, you need to subtract 7. So you do the inverse operation. Okay. Thinking about this, if we represent it as a bar model, this is what it looks like, right? So 13 lots of D at 7. Now, when we do that, we'll be left with 13D halfway in here. So what do you think would have happened now that you have 13D to get D? Of course, it's going to be to divide by 13. But take note, for the function machine, you're working from left to right. Okay, always remember that you're working from left to right. So if in your inverse operation, you're going to have to divide by 13 to get the input, which is D, then the correct operation for the function machine, the first step of the function machine, is to multiply by 13. Here is this one. This time we have a two-step function machine where it is missing. Again, if you have a think, what could we do? So here, Tommy completes the function machine like this. So this is what Tommy did. Tommy is clearly incorrect. Can you have a think and explain Tommy's mistake? Why might he has made this mistake? Of course, I'm sure you're thinking Tommy would have made this mistake because Tommy is thinking 7 plus 4r is different from 4r plus 7. They are the same thing. Remember our very early lessons, addition is commutative. So you can actually rewrite this. You don't have to stick to 7 plus 4r. To get you really thinking properly about how to resolve the problem, he could have simply rewritten this as 4r plus 7. So which means he needs to multiply by 4 first before adding 7. Okay. All right. Have a go at the rest of the questions. So you can pause the video and answer questions 5 and 6 for 4 minutes. Assuming you have paused the video and you've really thought about what you've learned, here are the answers. So here is the answer to question 5. Question 5, you're asked to draw a two-step function machine that has an input of y and gives an output of y, divide y over 2, add 5. Okay? So, y over 3, add 5. So for a two-step function machine, you're going to have to divide by 3 first, and then you add 5. Okay? And then here you're told to draw a two-step function machine that has an input of y and gives an output of y at 5 divided by 3. Of course, here, from what you've learned, you know it's clearly going to be y at 5 as first step of the function machine, and then divide by 3 as the second step of the function machine. And then you're asked, what is the same and what's different about each of the function machines? Of course, we can clearly see that it's the same operation but different order. So the order of operations affects the result. Here is the answer to question 6. Here you asked to complete the function machines. Okay, so we can clearly see looking at the inputs. So we have y, and then here all the way we have 5y minus 8. So it's clearly visible. Okay, remember one first, one of our early lessons, you can look at the first, first step going all the way from the input to the end, and then check the second one to make sure you're getting the same result. So for the first one, it's clear that we're multiplying by 5 and then we're subtracting 8. So we can check with the second one. That seems to work because 2b multiplied by 5 is 10b minus 8. So that works. Okay. And then to get the input, you simply do the inverse operation. So you can do 25c. The inverse of subtracting 8 is to add 8. So that gets rid of subtracting 8. You're now left with 25c. And then the inverse of multiplying by 5 is to divide by 5. And that gives you 25c divided by 5, which is 5c. And then here, we apply the same principle. Here is question 7 and 8. Pause the video and try to answer this in 3 minutes. Assuming you've done that, here are the answers. For question 7, you asked to complete these two-step function machines. Again, we apply the same principles we've learned. Okay, you have 7 plus 2e. All right. You're thinking, okay, my input was e. What could have happened? Okay, you could have multiplied by 2 and then added 7. Take note, this could have been rewritten if you were not sure as 2e add 7. So 2e plus 7. And this could have been rewritten as g over 5 plus 4. Okay, that way helps you find the solution quicker if you're unsure. Because remember, addition is commutative. And then here you ask, here is a function machine. Which of these expressions shows the output? Tick your answer. Okay, so you can see here x will multiply by 2 subtracted from 10. Okay, subtracted from 10. So it's important you read questions properly. This is not the same as 10. It's not the same as 2x minus 10. Okay, because we're subtracting whatever we have from 10. So it's going to be 10 minus 2x. Okay, that brings us to the end of our lesson. So what have we learned so far? In this lesson, you have learned that for a given input compared to a given output for a two-step function machine, you can find out the operations of the function machine by thinking about your input relative to your output, thinking how it has changed. And then if you think about the operations that would have given the result to your output, you can first work it out to see whether your output corresponds with what is already given to you. If it doesn't correspond, then try reversing the operations, because remember, the order of operations affects your results. Until next time, take care and bye-bye.